Hi, I'm Jack Buffington for robotbrigade.com. This is another video in my series of videos about a mapping robot that I'm working on. And this specifically is about the encoder code that I wrote for this robot. This code allows you to have up to 16 encoders. I'm currently using 2. And let's just go through the code. In your main program, you need to have a series of variables ordered in this order. And you can't stick anything in between any of these because when you call assembly language code in PASM, you're passing an address to it. And that will be the address of this variable right here. And then it will compute the where to look up for the other 3 here. So when you start the core, you are calling this, which launches the code at this label, which is right here. And you're passing this address, which is moved into the parameter variable. So initially I'm just loading that and putting it into an address that I go and start looking things up. And I won't go into as much detail as I did with my PWM code, but basically right here it is loading various variables. Here it's loading the encoder positions to get started. Now it is setting up a it has 2 loops. It has an outer loop that iterates through all of the encoders and an inner loop that takes care of just updating the position of a single encoder at a time. So we're setting up for the main loop here. The inner loop is here it's getting ready to call adjust encoders or adjust encoder. This is prep of the variable, so we're passing encoder position, we're passing the current encoder position, which is right justified, and the last encoder position, which is also right justified. Then we call, well, after we call that, then we get ready for the next round. In adjust encoder, I believe I'm doing this as quickly as possible, but there's always seems to be some little hack that lets you do it just a little bit faster with assembly. But anyway, the tricks that I'm using are that I am taking the last encoder and the current encoder, and I'm doing an exclusive OR of the 2. And if it comes out as 0 or 3, I'm choosing to do nothing. So if it's 0, then it has not, the encoder position has not changed. If it's 3, then both bits have changed and it's either glitching or it's moving so fast that it can't keep up. In which case, I mean, you have to do something, so I'm just going to ignore it. But this has not been a problem in my experience, at least with this robot. If I had a higher resolution encoder, it may become an issue. But this code is plenty fast, so at least if you have a couple of encoders, it's not going to be a problem. The code will slow down based on how many encoders you're reading. Okay, so once we've determined whether we're doing something or not, then we go over into this section of code. And what I'm doing is I'm taking, originally they're both aligned the same. I'm taking one of them and shifting it 1 position to the left. And then I'm doing an exclusive OR, and I am clearing the lowest bit. Actually, I'm clearing all but the second bits. And by looking at the value of that bit, it tells me whether it's gone this way or this way. And I adjust, here I'm doing the AND of the bit to clear just everything but that second bit. And I'm writing the 0 bit. If it is 0, then I'm subtracting 1 from the position. If it's not 0, this instruction right here will turn into a no-op. And then if it's not 0, then it adds 1 to the encoder position. Then it goes ahead and returns to right up, where did I call that? I don't know where I called it. Anyway, right here. It jumps back up to there. And it goes about its merry way forever. So yeah, I'm pretty happy with this code. It's working great in this robot. And if you like this video, I have other videos in this series where I'm talking about the code as well as everything about a mapping robot that I have built. So for robotbrigade.com, this is Jack Buffington.